Greetings, friends, family, and fellow commanders. Welcome to the 4th episode of the SHEPARD Chronicles. We are coming to you from the famous historical location simply known as the Roncevoux Crossing, more than 55,000 light years from Sol, our departure system. This video transmission will be a short summation of the various events and encounters along the Scutum-Centaurus Arm. The last 3 weeks have been an incredibly intense effort, traveling 46,000 light years in a span of only 3 weeks. As such, the portion of the Scutum-Centaurus Arm through which we have traveled has been less a detailed examination than it has an episodic survey. The effort was intense, the hours were long. This video transmission serves as a collection of various activities and findings along the route before we make the final push to Beagle Point. You may notice throughout this transmission as well that my ship is starting to rattle quite loudly. This has been noticeable for about the last 2 weeks. And while my hull remains at 90% integrity, I am beginning to feel the brevity of this mission. 6 months out in the black with literally no safety net. After leaving Waypoint 7, we quickly covered the last portion of Dryman's Ridge and reached the Scutum-Centaurus Arm. We didn't know what to expect. After the richness of discoveries over the course of Leg 1, most of us remained optimistic that these galactic anomalies would continue. Moreover, I was also excited to get into a lesser traveled region of the galaxy in the hopes of being the first to discover new astronomical data and new unique systems. Generally, the strip of the Scutum-Centaurus Arm that SHEPARD will traverse is relatively dry of known points of interest, with the exception of a few large nebula. This is partially because this region of space is so large that it just has not been mapped very well, which is one of the reasons SHEPARD is going along this route. The Scutum-Centaurus Arm is, however, incredibly rich with black holes and neutron stars and white dwarfs, and we will cover some of that in this video transmission. The southern reaches of the Scutum-Centaurus Arm were relatively uneventful. We used waypoints 8 and 9 mostly to catalog many neutron stars nearby, but in fairness, we were excited to keep moving, to keep cataloging different systems, as so much of this region is entirely unexplored. There were, however, a few systems worth noting along the way. I would like to take a brief moment to describe to you one of those systems, a remarkable high-mass ringed planet I saw orbiting within 10 light seconds of its F-type parent star. This planet was large, hot, and dense. In fact, the radius of this planet was almost 12,000 kilometers. In other words, the diameter of the Earth is equal to roughly half of this planet. Moreover, it contained 11 times the mass of the Earth, contributing to its high gravity of 3.32 Gs. What is most remarkable, however, about this high metal content planet is its atmosphere, composed of 98.5 silicates and 1.5% iron. The atmosphere is more like a gel than a gas. Breathing this atmosphere would be impossible, not because of its toxicity or odd flavor, but because humans would actually swallow the atmosphere rather than breathe it. Its atmospheric density, as such, of over 8 million times that of Earth, paired with its close proximity to its parent star, has caused the surface of this planet to reach temperatures of almost 15,000 degrees Fahrenheit. Okay, let's take a moment to think about exactly how hot this is. 8,357 degrees Kelvin on this planet. The sun in the solar system is only measured at 5,800 Kelvin, making this planet hotter than the surface of the sun. Now, because there is no actual surface of the sun, we measure stars' surface temperature from a region called a photosphere, which is a star's outer shell from which light is radiated. It extends into a star's surface until the plasma becomes opaque. In other words, a photosphere is the deepest region of a luminous object, usually a star, that is transparent to photons of certain wavelengths. So you may be asking yourself, just as I did upon discovery of this remarkable planet, why is it not on fire? Why is it not fusing hydrogen? Well, there are two reasons for this. First, the planet is far too small to have the gravitational pressure to cause nuclear fusion. Remember, fusion occurs because of intense gravity, which causes friction and pressure. It is primarily the process of fusion that creates heat, not the other way around. Secondly, while the photosphere of the sun is only 5,800 Kelvin, as described before, we also gauge stellar temperatures from the corona and the core. The corona of our Earth's sun is 5 million degrees Kelvin, and the core a whopping 15.7 million degrees Kelvin. So to say our little planet here is hotter than the sun may be a slight misnomer, but not entirely. Astronomically speaking, we gauge stars' temperature, which, remember, is what determines their classification, from their photosphere. So one could technically say the surface of this planet is hotter than the sun. A rare find indeed. Also known as Hawkin's Nebula, Waypoint 10 is a prominent and large nebula situated toward the western edge of the Scutum-Centaurus Arm, and is one of the first major fourth quadrant nebula that we will discover along this trip. One of the systems within the nebula contains a beautiful Earth-like world, nicknamed Douglas World, that, due to its stunning nebulous backdrop, may one day become a very distant tourism candidate once atmospheric shielding allows planet-side exploration. From the start of Leg 2 until Roncevoux Crossing, the SHEPARD mission only had one base camp. This is primarily because of the extreme distances and short time frame. However, the base camp we did scout, the one at Waypoint 10 named the Cereal Bowl, was reminiscent of old campfires I used to have in a forest near my house growing up. Scattered throughout the entire landscape were smoldering vents through which molten hot iron magma punctured the surface. It is possible that in distant history, this crater was actually a large volcano that has since subsided because of its cooling core. Regardless, many of the SHEPARD commanders took time to meet nearby, share stories from our journey so far, and even enjoy some of that fine Lavian brandy brought along in our cargo holds. Sightings like these are rare, so we spent much time driving around the base camp, admiring its beauty, before getting into our ship-launched fighters for some high-speed surface reconnaissance. Commander Tane and I gathered our small vessels together for some photos in formation, often very close to the planet's surface, before flying our fighters in and out of canyons, boosting our thrusters to their max, myself testing the limits of my Imperial fighter, Scout class. From high altitudes, one may notice the canyons, and indeed the rims of a few craters had a calcium powder on its surface, with a blue-green tint, likely the result from the chemical composition of the planet during its hotter phases when it was first being formed. These minerals have since dried up, and they stick to the surface like glue. We did some surface prospecting in a few of these areas, and I'm happy to report I found multiple rare materials I gathered and stored in my ship. The short distance between waypoint 10 and 11 is populated with literally hundreds of unexplored neutron stars and white dwarfs. I journeyed to roughly 30 of these along the way, which may seem like many, but I likely covered only a very small percentage of these high-mass objects, perhaps 5% at most. While I did visit many of these systems, scanning the stars and collecting their data, I had to quickly move on. Remember that whole bit I mentioned about reaching Beagle Point by Christmas? I was also beginning to experience some malfunctioning of my frameshift drive. The seemingly perpetual repetition of supercharging my frameshift drive with their hot outgassing is causing collective damage, and I'm trying not to repair my systems too often. I would like to complete Leg 2 if I can. Not to mention the monotony of the situation. Finding a single or pair of neutron stars where they don't often appear is fantastic, but when your ship is literally surrounded by them, it can be a little overwhelming. Tedium no more, I had to get going. And did I mention, I am also getting very close to visiting my 10,000th system, a milestone saved for only the most avid explorers. Nearby, to recharge my spirits, I discovered a very large water world with its own water world moon, itself terraformable. This pair of water worlds is a distant 5,600 light seconds from its A-class star, which is farther than the planet Saturn in the Sol system. The largest of the two was 1,600 kilometers in radius, only 4,000 kilometers from the largest known water world. These two I had to get closer to inspect, and I was not disappointed. In another A-class system, only 40 light-years away, I discovered another water world, far away from its parent star. This one was in binary, but more importantly, had an incredible ring system made of over 24 thin bands of narrow but dense rocky rings. The light reflecting from their surface was sharp and crisp. Marking the southern edge of the region of space known as the Ascendants, there rests a quiet yet dangerous nebula. Its colloquial designation is the Eye of Horror Planetary Nebula and is a contact point of interest and designated as a medium-grade exploration hazard by the Galactic Mapping Project. Embedded within this blue planetary nebula is a K-class star orbited by a close proximity black hole. Explorers visiting this system need to be wary of their hyperspace orientation on approach, due to the possibility of exiting between the primary star and its deadly companion. After this planetary nebula, it was time for me to enter the Ascendants, a region in the Scutum-Centaurus Arm east of the galactic core, stretching from the Eye of Horror planetary nebula and unto the Scutum Outer Beacon. The Ascendants provides an alternative access to the Bleak Lands and the galactic aphelion for ships with limited jump range who are unable to cross the Styx. I designated myself the difficult task of traversing the entirety of the Ascendants over the course of one Earth night, an endurance slingshot through the region, cataloging any oddities along the way. Sadly, the Ascendants was a relatively dry wasteland. There were very few systems sustaining life. In fact, throughout my journey, albeit brief, I did not catalog a single Earth-like world. This might be significant. Bear in mind, I already tagged over 15 Earth-like worlds prior to the Ascendants. Most of this leg was filled with neutron stars and multiple body A and B systems, each with their own assortment of T Tauri stars and gas giants. Along the way through the Ascendants, I stumbled upon, yet again, another A-class system, with many landable planets and moons. However, that is not what caught my eye. While exploring, especially during these long stretches, it is important not to only focus on trying to find limited specific types of data, such as Earth-like worlds or water worlds, but to rather keep your eyes tuned to the larger picture, or indeed it might just slip right by. In this case, one could have easily missed a wonderful and unique ring system. My scanners found a large L-class ringed dwarf right in the middle of the system, with a very peculiar single ring system surrounding it. This ring was massive, in fact, the largest I have ever found, with its outer edge reaching 24 million kilometers. What makes this ring even more unique is that its inner edge was actually 14.5 kilometers from the star, leaving a gaping void between the star and ring, in which actually a satellite moon was orbiting. Toward the end of a long night of seemingly endless travel, along the northern portions of the Ascendants, immediately before the Flying Flea Nebula at waypoint 13, I found my final neutron star of the day. Very deep in the neutron star fields of the Scutum-Centaurus Arm, this binary system featured a white dwarf as the primary star and a very small neutron star orbiting it. The rate of its revolutions was remarkable, and made for some excellent video footage and a break from the long journey. I scanned both the stars, took some footage, and found a landable planet in a nearby system to get some sleep. Space is dangerous, especially on limited sleep around a binary neutron star. Waypoint 13 is a large purple nebula known by explorers as the Flying Flea Nebula. Relatively uneventful, Flying Flea is a small emission nebula in the heart of the Scutum-Centaurus Arm and the first in the fourth quadrant region. It is home to approximately 105 stellar systems, including an Earth-like world and a water giant. While searching these various nebula, we are trying to satisfy one of the goals of the SHEPARD Mission, which is to find astronomical bodies that break known records in the Universal Cartographic System. We are trying to discover the limits of astrophysics, How large, small, dense, old, or young can certain astronomical bodies be before changing their composition entirely? It is a hope that once the SHEPARD mission is complete, we will have collectively rewritten the record books, expanding the knowledge base that we currently have about our galaxy. That being said, I want to, therefore, transmit some data about 2 record-breaking bodies I discovered along Leg 2. Well, the first one is not so much a record breaker, but a record tire. This CN carbon star I discovered is actually tied with the current record holder for 2 records. In fact, both the small and the least massive. With a solar radius of 29.0907 and a solar mass of 0.9297, this carbon star is exactly the same size and mass as the smallest known CN carbon star. While this may merely be a coincidence, it may also mean that carbon stars may reach a limit before they actually break down, losing their core entirely. As hard as it may be to believe, however, I actually think that these 2 stars are merely coincidental, judging solely from the fact that we have surveyed so little of our galaxy as human beings. As of this transmission, less than 0.0025% of the galaxy has been discovered, meaning at this rate it will take over 70,000 years to discover it entirely. As such, I find it entirely more likely that not enough CN carbon stars have been scanned to offer enough data on their size and mass limitations. That being said, and even though this system only tied the existing record, it was a fantastic find, and certainly made the long trip to Roncevoux Crossing that much more enjoyable. While the CN star I cataloged was merely a record-tying entry, I would like to now transmit information on a record-shattering entry. High above waypoint 13, just before entering the Bleak Lands, I encountered this dark and stunning planet. A rocky, icy world, this leathery ball of densely packed frozen mud measured in at an astounding 16,332 kilometer radius. Moreover, my detailed surface scanner indicated that this planet is 29 times more massive than Earth. While its atmosphere was very thin, it was composed of 93% water, likely resulting from its very high concentration of active silicate vapor geysers. These factors combined caused the planet to have more than 6 million times the atmospheric pressure on Earth. The absolute magnitude of this rocky, icy planet, therefore, broke not 1 record, but 3. While not the largest discovered, the current record holder for mass is 21 Earth masses. My planet, which I have subsequently called Procyon, was 29 Earth masses, an increase of 140% more mass. Secondly, Procyon had a surface pressure of 6 million atmospheres, which destroys the current record for a rocky, icy body by 20%, coming in at just under 5 million atmospheres. And finally, the hottest known rocky, icy planet is 3,000 Kelvin, whereas Procyon registered at 4,700 Kelvin surface temperature, an increase of over 50% from the existing record. Alas, I have finally found my first astronomical record. 6 weeks into our expedition and since our departure. So I decided to spend a long time in this system, and particularly in orbit around the newly discovered mammoth Procyon. Finally, after waypoint 13 and the long path across the bleak lands and into the abyss, we finally arrived at waypoint 14, the now infamous Roncevoux Crossing system, in a region of space simply known as the Abyss. The Roncevoux Crossing dates back to the early pioneers of exploration, and is the point at which a 25.8 light-year range Cobra Mark III, known as the Roncevoux, successfully crossed the eastern edge of the abyss into the outer galactic regions. Thus, this region marks the liminal point in exploration cartography, as travelers using shorter-range craft attempting to reach the most distant suns on the outer galactic arm, such as Beagle Point, are advised to begin their journey across the abyss east of this location. The system itself is a pair of binary B-class stars with two nested T-Tauri stars, each with their own rocky world moons. SHEPARD commanders gathered on the farthest moon to repair our ships and prepare for the final jaunt to Beagle Point in the Solitude Void. We have named this base camp Glenn's Passage, in honor of our fallen hero, John Glenn, who, like Alan Shepard, pushed the limits of human exploration. This base camp features a remarkable canyon with steep mountain cliffs, and the galactic sky is noticeably darker here, making planetary features sometimes difficult to discern. We truly are in the black. Two other commanders, Ethereal Serial and Commander Tane, joined me in their anacondas for a few photographic mementos honoring the occasion. But soon it was time to leave. The next few days are going to be tough, crossing 13,000 light years in 3 days. But the reward? To be at Beagle Point on Christmas morning? Will most certainly be worth it. While difficult, this next push will be memorable, and I, Cmdr Parabolus, am looking forward to sending news of our arrival on the next video transmission. Godspeed, Commanders. If you liked this video or enjoyed its contents, please give it a thumbs up or subscribe to my channel. Or better yet, just recommend and share it to someone you might think would also enjoy it. Until next time, this is Cmdr Parabolus, signing off.